Find the values of the trigonometric functions of t from the given information. Tangent of t equals 1 over 6. Terminal point of t is in quadrant 3. Okay, so what we're looking at here is the fact that there are 6 trigonometric functions that have been discussed in your trigonometry class. This is going to be based upon right-angle trigonometry or unit circle trigonometry. Now, when we look at these, we want to make sure that we understand what it is that we're looking for. We're given the tangent function, which means that there are 5 other functions remaining that we need to find the values for. They're going to be the sine of t, cosine of t, the cotangent of t, the secant of t, and the cosecant of t. Now, depending upon the textbook you're using and the way the problems might be set up, instead of using t, they might use angle theta. And you can use A or B or alpha, beta, whatever. Doesn't really matter. What we're understanding is that this value inside the parentheses represents an angle. Now, we have to remember that there are relationships established for each of the 6 trigonometric functions based upon the sides of a right triangle, whether that's a right triangle independent of the unit circle or whether we're using the unit circle. In this case, we're going to go ahead and understand that we're looking at quadrant 3. Doesn't necessarily have to be the unit circle, but it is going to be a circle of some point, and we can just simply sketch out a Cartesian coordinate system. Doesn't have to be 100% accurate. I know this is my y-axis and this is my x-axis. I know that the terminal point of the angle that we're discussing is going to be in quadrant 3. And since this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4, I know that my point is somewhere here. Doesn't really matter if I'm 100% accurate on it. All I'm trying to do is get a rough estimate. I'm going to go ahead and draw the terminal side of my angle, and I'm looking at this angle t or theta, whichever notation is being used. Now, what I can do is go ahead and understand that if I draw a right triangle so that the y side of the triangle intersects the point and also intersects the x-axis and is perpendicular to the x-axis, I have a right triangle here. And what we're going to do is use the terms for the right triangle trigonometry. If this is my angle here, and we're really going to be looking at this interior angle here, we know that this is going to be my x side, or it's also going to be our adjacent side. This is going to be our y side. It's also going to be called the opposite side. This right here is our hypotenuse, which I will use a capital H to represent. Now, I've got 5 of the trigonometric functions listed. I'm going to go ahead and list the one that's given to us, because what I want to do is describe the relationships that are given. The sine function is defined as the opposite side of the triangle over the hypotenuse, so O over H. The cosine is defined as adjacent side over hypotenuse. The tangent is defined as the opposite over the adjacent. And the cotangent, secant, and cosecant are going to be reciprocals of their associated trig functions. For example, when we look at this, the sine function is going to be associated with the cosecant function. Therefore, the cosecant function will be the hypotenuse over the opposite side, which is just the reciprocal of the sine function. And likewise, the cosecant function is going to be related to the secant function because it's a reciprocal, and this will be the hypotenuse over the adjacent side. And then finally, the cotangent function will be associated with the tangent function. It will be the reciprocal, and we'll have adjacent over opposite. But now we need to know what our adjacent, opposite, and hypotenuse lengths are in order to determine what the values of those sine functions of t are. We're given the fact that the tangent of t is equal to 1 over 6. We note that the tangent of t is the opposite over the adjacent side. So if this is equal to 1 over 6, that means that the opposite side is going to have a length of 1, and the adjacent side is going to have a length of 6. And now I can use that to find the missing component, the hypotenuse. I'll use the Pythagorean theorem, and simply using OA and H as our notation, h squared is going to be equal to a squared plus o squared, which means that h is equal to the square root of a squared plus o squared. And if a is equal to 6 in this case, and o is equal to 1 in this case, I know that h will be equal to the square root of 6 squared plus 1 squared, which will give me, simply stated, the square root of 37. Because 6 squared is 36, 1 squared is 1, 36 plus 1 is 37. Leave it in exact form. Do not find a decimal equivalent. And now what I know, and let me write out my list, is that the opposite side is equal to 1, my adjacent side is equal to 6, and my hypotenuse is equal to the square root of 37. So now I'm just going to plug values into the ratios that are given. The sine of t is going to be given as the opposite side over the hypotenuse. This is perfectly acceptable unless you are required to rationalize this. If you rationalize it, you're going to multiply both the numerator and the denominator by the square root of 37, which means that your answer can be put into an alternative form of square root of 37 over 37. Now, I need to point out that we're missing a component here because this is in the third quadrant, and in the third quadrant, we know that x and y are both negative, which means that the ordered pair right here is actually going to be -6, -1. And I have to include that in my discussion. And so this is actually a -1 and a -6 when I go ahead to plug these into my trigonometric relationships. So I need to make sure that I go ahead and realize that this is a -1, which means that this simplification or rationalization is going to be negative. So now let's talk about the cosine of t, which is adjacent over hypotenuse, which in this case will be -6 over the square root of 37. Once again, I can go ahead and rationalize this by multiplying by the square root of 37 over the square root of 37. And that's simply going to give me -6 square root of 37 over 37. The cotangent is the reciprocal of the tangent, so therefore the cotangent of t is going to be equal to 6 over 1, or simply 6. Now, the secant of t is going to be the reciprocal of the cosine of t. I don't have to go to this and take the reciprocal of this because I'm going to go ahead and use the non-rationalized form and simply end up with the square root of 37 over -6, which I could write as a negative square root of 37 over 6. And then likewise with the cosecant of t, that's going to be the reciprocal of the sine function. So I will simply take the reciprocal here, and that's going to be equal to square root of 37 over -1, which I can simply write as negative square root of 37. Now, there's a number of different ways to actually write this out and different notations. And just using your critical thinking skills, you can apply what we've written here to any of the 6 trigonometric functions given one of the functions and what it's equal to.